Hi guys, I Dr. Gurmeet Singh Basan welcome you all on my second video on the projection of solids of engineering drawing. In my first video I have discussed about basics of projections, fundamentals of solids and its classifications only. So basic thing we discussed in my first video, and now we are going on a second stage where we discuss about the various aspects of the solids keeping on the HP or VP and inclined to one of the plane. So in this video I will be discussing about solving single stage as well as the double stage problems which is inclined to one plane, and also giving you a unique tips hints to solve any examples of projection of solids quickly and correctly. Remember, I will give you the unique hint or the tips which is very important to solve the problems of solid very easily, very quickly, without any problem. So before going to the main topic, guys, let us brush up your basic knowledge of the projection first. Hi guys. Now here, before going to solving the examples of projection of solids, you must be knowing about the first angle projection method and the third angle projection method. That you already have learned in your previous chapters. Let us brush up it. And now, to get the first angle projection method and the third angle projection method, you must be knowing it as what are the quadrants also. So let us discuss about the 2D and the 3D view of the four quadrants and the first angle and the third angle projection method. So first is a horizontal plane. Okay. So in 3D you are seeing the horizontal plane, and in 2D we are getting a straight horizontal line of the horizontal plane. And we know that what view we are getting on the horizontal plane. So we always get the top view in the horizontal plane. The vertical plane is perpendicular to the horizontal plane. Okay, that you are seeing here. And in 2D, we are taking the perpendicular line to horizontal plane. That will give you the vertical position of the vertical plane. And you also know that on vertical plane we are getting the front view of the object. Okay, and if we see all the four quadrants from here, then your XY line will be seen as a single point on the two-dimensional view, that is X and Y here. Now these are the four quadrants, and how we are keeping the object in the four quadrant, and how we are getting the front view and the top view, and what will be the position, that we are discussing here. Okay, so here, to get the projection, always the observer is on the right hand side. So we see the object from right side towards the left hand portion, irrespective of the position of the object in any of these four quadrants. Okay, so always we see the object from the right hand side. Now in the first quadrant, so what would be the position of any object with respect to the horizontal plane and the vertical plane? So in first quadrant, obviously the object is above HP and in front of VP. So whenever anything is written in the data above HP and in front of VP, that means the object has been kept in the first quadrant. Similarly, we go for the second quadrant. So in the second quadrant, what would be the position? It is above HP and it is behind VP. Okay. Now in the third quadrant. So in third quadrant it is below HP and behind VP. That is the position of the object in the third quadrant. And in the fourth quadrant, it is below HP and in front of VP. So that would be the position with respect to the fourth quadrant. So here, whenever these wordings have been given in the data, so from this wording, you should identify in which quadrant the object has been kept. So this is very, very important. And here, if we are not getting the three-dimensional view every time. So for that, what we are doing, we rotate the horizontal plane in clockwise direction through 90 degrees, so that horizontal plane is merged with the vertical plane. And for that we are drawing it, that is to be known as a projection. Okay, so when we are rotating the horizontal plane through 90 degrees, so it will merge with the vertical plane, then Obviously, in first quadrant, what would be the position? So it is your front view will be above XY line and the top view will be below XY line as we are rotating horizontal plane through 90 degree in the clockwise direction. So top view will be coming on the below XY line. What would be the position of the top view and the front view in case of the second quadrant? So front view will be above here. So you are getting top view here as we rotate in clockwise direction. So front view and the top view both will be above XY line if we keep the object in the second quadrant. So what would be the position in case of the third quadrant? So it is front view is below XY line. Okay. Your top view will be here as we rotate through 90 degrees. So your top view will be above XY line. So while keeping the object in the third quadrant, your front view is below XY line and your top view is always above XY line. Okay. And if we keep the object in the fourth quadrant, then your front view is below XY line and as we rotate the horizontal plane through 90 degrees, your top view will also come below the XY line. So here in second and fourth quadrant, the front view and the top view, they are merging with each other. So in the second quadrant, they are both above XY line and in the fourth quadrant, they are both below XY line. So that means your front view and top view, the lines of the front view and top view, they are merging with each other. So you cannot identify which line you are drawn for the front view and which line you are drawn for the top view. So that is why we are not adopting the method for second and fourth quadrant, and that is why universally it has been accepted that first angle and the third angle projection method. So if we keep the object in the first quadrant, okay, so always you see the object from the right hand side. So your object is in between the observer and the plane. Okay, so whatever you see from the front side, you are getting on the rear side. Whatever you see from the top, you are getting at the below side. And whatever you see from the left hand side, that you are getting on the right hand side. So this is the main thing about the first angle projection method. So if we keep the object in the third quadrant, and always you are seeing from the right hand side. So here in the third quadrant, your plane is in between observer and the object. So your plane is between observer and the object. So on whatever direction you are seeing the object, on the same direction you are getting the view. Okay. So you are getting the front view below XY line. Your top view will be above XY line. So if you see the object from the left hand side view will be on the left hand side, and your right hand side view will be on the right hand side. So this is the basics about the projection method, that is the first angle projection method and the third angle projection. So these are the basics which you have to use it while you have to solve the projection of solids. Now we go about the basics of the projection of solid. So in the first case, we take the axis perpendicular to HP. So when axis is perpendicular to HP, that means it is parallel to both VP and the profile plane. Okay. So let us take an example of the square pyramid. Okay, we are keeping it on horizontal plane and the axis is perpendicular to the horizontal plane. So here, this is your XY line, and here if you see from the top, O is here, that is the vertex end. So whenever an axis is perpendicular to HP, so we see the shape of the object in the top view only. So in this case, when axis is perpendicular to HP, we have to draw the top view first. So what is the shape of the top view? It obviously is a square. That is ABCD. That is the base of the particular square pyramid. Okay. So ABCD is here. So that would be seen in a two-dimensional view as A, B, C is here. That would be shown here. D is here. That would be shown as here. And the vertex point, that would be projected at the midpoint of the square. So here AC and BD, when we are joining it, the intersecting point, that would be your vertex point. Okay, so always when axis is perpendicular to HP, we have to draw the view in which we are getting the shape. Okay, so we are drawing the top view first, and from top view we take the projections, that is on the front view. Okay, so in front view, A and B are on the same line, so we are getting A dash B as a single point here, that we are seeing in the XY line. C and D, they are on the same point, so that is my C dash and D dash will be projected here, so that will be C dash and D dash here. Okay, the axis is from the O. We draw the projection, that will be your axis length, and depending upon the given dimensions of the axis length, okay, mark point O dash here and join O dash with A dash B dash and O dash with the C dash and D dash. So this is how we can get the projection when axis is perpendicular to HP, and obviously it is parallel to VP as well as the profile plane. Okay, now we go for the second class, in which the axis is perpendicular to VP and hence it is parallel to both HP and profile plane. So here let us take an example. Now what is this solid? It is a prism because it has two bases, and depending upon the shape, what is the shape? It is a hexagonal shape. So this solid is hexagonal prism. Okay, so here because it is a prism, it has two bases, one basis as well as the second basis. So draw XY first. Now as the axis is perpendicular to VP, okay, so we have to draw the front view first. So in front view, this is A, B, C, D, E and F. So this is the front portion of the prism, and this will be the corresponding rear surface of the rear base of the prism. 1, 2, 3, 4, 5, 6. Okay. Now as we see from the front side, so A and 1 will be merging here. So you are getting A dash 1 dash on the vertical plane as a single point. Similarly, you are getting B and 2, that will be a single point, that is okay, that we can project the A dash 1 dash here. B and 2, that would be a single point here, that is B dash 2 dash, that we will keep it here, that is B dash and 2 dash. Similarly, we can go for C and 3 point, that is C dash and 3 dash, D dash and 4 dash, E dash and 5 will be here, okay, that would be projected here, and 6 and F will be on this point, so that is F dash and 6 dash will be here. Okay, so this is how we can project the front surface and the rear surface of the prism on vertical plane, and we are getting the front view of this particular solid on your two-dimensional figure. Okay, now as we draw the front view first, then from front view take the projections, and we are getting the top view at the horizontal plane. So while taking the top view from the top, okay, so this is the H, which is the axis length has been given. Okay, now A will be projected here, A, and that would be shown from here. 1 is projected on the other side. Okay, so 1 dash is here, so that will be projected on here, that will be 1. Same way we have to project all the points on the horizontal plane. Okay, so that would be BF, and this will be 2 and 6, that is C and E, that is C and E here, 3 and 5 is here, 3 and 5 will be here. Okay, D is here, so D will be projected from here, D is here, and 4 will be on the opposite side, that is 4 here. Join all these points and we are getting the top view of this particular solid when we are keeping the axis perpendicular to VP, so that obviously your axis is parallel to the horizontal plane as well as parallel to your profile plane also. Okay, this is the second case. In the third case, we take the axis perpendicular to the profile plane, hence parallel to both HP and VP. So here, this solid, which is this solid, it is a triangular prism. Okay, and in triangular prism, we are keeping the axis perpendicular to the profile plane, and we are drawing the XY line here because in this case you get the actual shape of the base in profile plane. So obviously you have to start drawing your view, that is a side view in which you are getting the actual shape of the base from the profile plane. So we have to start drawing with the profile plane, that is a side view. So A is here, B is here, C is here. This is the first face which is getting from the side view, and the opposite face is 1, 2 and 3, that is on the opposite side. Okay, so as we see from the side, A and B will merging here, so you are getting A double dash 1 double dash here, B and 2 that will be merging here, and you are getting a single point on here. Okay, so this is A dash, A double dash and 1 double dash. Okay, this is B double dash and 2 double dash, that you are getting it in this particular corner. And C and 3 will be here, so that will be C double dash 3 double dash here, and you are getting C double dash and 3 double dash here. Now one more thing I would like to tell you, that notation is very important in engineering drawing. So you must be knowing that for showing the notation in front view, we are showing the small letter with dash. To show the notation of top view, we are showing only the small letters, and to show for the side view, we are showing the double dash. Okay, so this double dash, it indicates that we are showing for the side view. Okay, now to get the front view, okay, you must be knowing the concept of the orthographic projection also before going to this. So we have to take the projections from the side view. Okay, so this is L. So take the projections from the side view. So from the side view, if you see from the front side, A and B will be merging here. So A dash B dash will be shown here. So that will be A dash B dash is here. So 2 and 1 will be merging here. So that is 2 dash or 1 dash will be point here. So that is your 2 dash and 1 dash point is here. Okay. C is at the top. So when you see the C from the front side, you are getting C dash here. So that would be C dash from this position. We are getting the projection C dash here. And 3 will be projected on the plane, that is vertical plane, that will be 3 dash here. So 3 dash will be shown here. So this is how we are getting the front view. Now if you see the object from the top, you also get the rectangle. But how will you get the position of the top view? Okay, so in the concept of orthographic projection, you must be knowing that the top view has 2 dimensions. What are the 2 dimensions? Length as well as width. Okay, so length you can get it from the front view, and the width or the breadth you can get it from the side view. So length already we are projecting from here, and for the breadth or the width we have to take the projections from the side view. Okay, so from here, this is the axis which we are projecting here. This is the one end which we project, okay, here on XY line. Okay, draw 45-degree line to project it on the another axis which is X1, Y1, and you get the projection on the top view. Okay, then third point, okay, this is the A point. So A will be here. So B, when you see from the top, you are getting B here, and one point is here. So one point will be on this opposite side. Okay, now we go projecting the B dash and 2 double dash. So that is B is projected here. So we are getting B here. 2 will be projected here. We are getting the 2 point which is to be at this point. Now we are projecting C and 3. So as you will see from the top, okay, the length or your height is merged with your projection side. So you are not seeing the height in case of the top view. Okay, so C will be seen from here at this point, and the 3 will be point on this point. Okay, so you are getting the top view of this particular solid by showing in this particular case. Okay, so be remember that whenever the axis is perpendicular to the profile plane, you have to draw the side view first and take the projection from side view you are getting the front view as well as the top view also. So these are the basic three cases where we keep the solid perpendicular to any one of the plane, and obviously that would be perpendicular parallel to other two principal planes. Okay.